platform with great tools, accelerated graphics, this very rich and immersive experience. The tools we showed enabled rapid and scalable development of these Metro-style apps. Touch-enabled controls, a whole library of controls natively built into Windows that you can use. Layouts, we showed grid layout, but there's a lot of work around layout, and all the templates in the tools as well. And you have your choice of world-class development tools and languages. JavaScript, C#, VB, C++, C, HTML, CSS, XAML, all for x86, 64, and ARM. This is an extremely important point. If you go and build your Metro-style app in JavaScript and HTML, in C# or in XAML, that app will just run when there's ARM hardware available. So you don't have to worry about that. Just write your application in HTML5, JavaScript, in C# and XAML, and your application runs across all the hardware that Windows 8 supports. And if you want to write native code, we're going to help you do that as well and make it so that you can cross-compile into the other platforms as well. So full platform support with these Metro-style applications. Now, what's the opportunity? I said at the beginning of this talk, we're here to launch an opportunity. The opportunity for building these applications is Windows. These applications will run on all new Windows 8 PCs, desktop, laptops, Windows tablets, small, big screens, all-in-ones. Every Windows 8 PC, whether it's a new PC or an upgrade from Windows 7, is your target customer. Do you realize that could be 400 million people when this product launches? That's a market opportunity for all of you. So now let's talk about, oh, go ahead. So next up, I want to talk about hardware a little bit. Because, wow, we showed some new hardware over here, but you know, there aren't any Windows 8 PCs yet. We're just getting started with that. A lot of you in this audience are the ones who are going to help us make the hardware and peripherals for Windows 8. But what I'd like to do is invite Michael Angiulo up on stage, and he's the Corporate Vice President for the Windows Planning and Ecosystem, and we're going to show you some of the coolest devices and hardware support that's available in Windows 8.
We have music.
We have music.
So, everybody wants a Windows PC that boots faster, that has a battery that lasts longer, that has a great graphics, display, visuals, touch, sensors, and fits into the thinnest, lightest form factors ever. Let me show you some of the advancements we're making in Win 8. So, Windows 8 supports PCs of the widest possible range. ARM processors, 600 processor servers with 4 terabytes of RAM. Go ahead and fire this one up.
Yeah, Airport X-Ray gave me a hard time with this one.
Yeah, this is an enthusiast system that's built with AMI firmware. It's kind of an extreme system. But the last time I did a boot demo was when we launched Windows 7. We had an Acer that booted in 15... see, it's almost faster than the monitor can turn on. That's UEFI fast boot. That was a full cold boot. That wasn't hibernate. That wasn't anything.
It actually... Most of the time, we're just the fan spinning up on this thing.
It can start faster than the fan sometimes. And it's not just reserved, like UEFI performance isn't just for big, crazy, powerful systems. This is the PC that you blogged about in the boot performance blog. And you know, when you see it start up, you see that you don't have like BIOS screens flashing like DOS characters and stuff. 8 seconds. This is an in-market, shipping today PC.
This is a Windows 7 PC.
It's a Windows 7 PC in market today, but UEFI is really important because it's not just about speed and having a boot that looks better, it's about security too. So I'm going to boot this PC, except I'm going to do it from this infected USB key. This has got a rootkit virus on it, which is a really nasty piece of malware because you boot from it and your machine would be owned before any software-based security could possibly keep up, but not with UEFI. I'm going to put it in here. Say boot from USB, and you can see it booting. Probably see it flashing. Boom. Boom. That's it. Invalid signature. And so what happened was UEFI checked the boot volume. It had been compromised. And now I'm going to turn this off and turn it back on, and it'll be right back to normal. This is just one of the security features that we have in the product.
Yeah, there's tons of security features. Like if this machine also had been using BitLocker, then you can't even rip the drive out and use it in other places. So a full range of security software. In fact, one of the things that we've got in Windows 8 is we've taken Defender and we've actually built a whole new range of protection all the way up through anti-malware, antivirus. All of that is built into Defender should you want to choose to use it, or you could use your own security software. But when I showed you that working set earlier, that 281 meg, antivirus was running in there as well.
And this is actually an encrypted drive while it's running, so the security's everywhere. So It's good stuff because all Windows 8 PCs will be faster and more secure as a result. And there's a whole new class of Windows 8 PCs that are going to come into existence based on the new advancements in SoC hardware.
Yeah, and so like the job of OS is really to abstract out all the hardware for you so that you can take advantage of all the unique hardware. And as I said earlier, what we really want to do is make sure that the unique value of each hardware also shines through in Windows, whether it's graphics cards or system on a chip or any of the hardware. And so we've got some cool demos of some ARM hardware here.
Yeah, ARM and SoC hardware combined. This is a Qualcomm ARM reference design. This is the one we showed at Computex. It's an 8660 Snapdragon. It's hooked up to this debugging system here that's measuring power really accurately. And what's going on this monitor is you can actually see the amount of power being used. It's very low. The system's not off. It's in a new power state called connected standby, which is a really low power idle state. You can see these little spikes that show up here. What's going on is Windows is coalescing all of the timer requests and all of the network requests, turning the radio on briefly, updating the apps, and then shutting the radio back down. So when I turn the system on, it turns on with one click, well, or two, depending on if you have demo gremlins. The system's on. You can see the power jumps right up. It's an instant on type scenario because it was never off. I can interact with the system here, and you can see the power kind of changes as we're rendering and we're drawing on the screen. And then when I go to turn it off, I click it. Immediately, the power drops down. What's going on right there is the apps get a chance to pack up their data, and then it's shutting down, and then it immediately drops back to idle. That's the kind of system.
Yeah. I mean, so when we talk about fundamental performance, that's what we're talking about. We're actually taking the things that you experience like in phones, and we're bringing that to the PC architecture at the base kernel level.
And it's one of the things that all of these SoC systems will be able to do. If you go to the Understanding Connected Standby session, you'll see the same power demo running on the NVIDIA Tegra 3. We showed, like, it was 9 months ago at CES. So the first time we showed ARM booting at all. And all it could do is like just boot Windows 8 up to the desktop and like one touch.
Yeah, I mean, it was just like a motherboard demo.
We've made a lot of progress since then. We've got everything running here. We've got fast graphics, the kinds of apps that Julie was running. They're all the exact same apps. I can go back to the beginning. I can launch another app.
So it sticks to your finger touch running on this prototype hardware.
Yeah, it's fast, it's performant. They're the same build of those apps running here, the same build of those apps running on this TI system. This is an OMAP system, a 4430. And for the first time, no one's seen this one yet. This is an Intel system. This is an Intel 32 nanometer Atom-based SoC development vehicle. I don't know if they're working on the name yet, but they're working on the power.
Yeah, I mean, it's so cool. Our partnership with Intel is great, and we're really excited to be able to show you that the progress that they're making on all of this kind of low-power work as well.
From SoC to high-power systems. I have a couple high-power systems here, too. So that performance thing is at both ends of the spectrum,
yeah.
Tiny systems and enthusiast systems. So this is an HP enthusiast system. It's called the Phoenix. It's going to be announced later this week, the full specs. Obviously, it's just announced now. But what I've got here is a USB 2.0/3.0 demo. So this has two drives inside of it. The one on top that I have open is USB 2, and the one on the bottom is USB 3. Now I'm going to copy a 1 gigabyte. I'm going to select and copy. Sorry, I've got to stay out of the way of the camera. A 1 gigabyte file here, and you can see the new progress indicator. And while that's copying, I'm going to grab a 1 gigabyte file from my USB 3 drive and show how much faster USB 3 copies.